Next, we will solve some gate questions on Laplace transform. The first question that we are solving here is such that a signal g of t is given. The signal g of t is from 3 to 5. The amplitude is 1. We have to find the Laplace transform of g of t. The signal g of t here can be expressed as in terms of unit step. The signal g of t can be written as u of t minus 3 minus u of t minus 5, because it starts from 3 ends at 5. So it can be written as u of t minus 3 minus u of t minus 5. If we apply the Laplace transform, capital G of s will be equal to, as we have seen that for unit step the Laplace transform is 1 by s. For u of t minus 3, the Laplace transform will be e raised to minus 3s by s. And u of t minus 5, the Laplace transform will be e raised to minus 5s divided by s. Therefore, for u of t minus 3, this will be e raised to minus 3s by s, minus this will be e raised to minus 5s by s. These two Laplace transforms are calculated by using the time shifting property. Therefore, the final answer for the given question will be e raised to minus 3s by s divided by e raised to minus 5s by s. What we can do is, we can also take e raised to minus 3s divided by s outside. Therefore, this will become e raised to minus 3s by s into 1 minus e raised to minus 2s. I hope you have understood the solution to this question. In the next question, capital X of s is given to us. We have to find the inverse Laplace transform. We will solve this question by partial fraction expansion. Therefore, the question s plus 5 divided by s plus 1 into s plus 3. We can write, if you apply partial fraction, we can write this as a upon s plus 1 plus b upon s plus 3. We have to find a and b. A is given as limit s is tending to minus 1, s plus 1 into capital X of s by s. Therefore, this will be limit s is tending to minus 1, s plus 1 into capital X of s is s plus 5 divided by s plus 1 into s plus 3. S plus 1 will get cancelled. Therefore, a will come out to be minus 1 plus 5 divided by minus 1 plus 3. So, a comes out to be 2. Similarly, we can find the value of b. B will be limit s is tending to minus 3, s plus 3 into capital X of s. Therefore, this will be limit s is tending to minus 3, s plus 3, s plus 5 divided by s plus 1 into s plus 3. The s plus 3 will get cancelled. Therefore, b comes out to be limit. We will substitute the value of minus 3. So, this will be minus 3 plus 5 divided by minus 3 plus 1. This answer would come out to be minus 1. Hence, if we substitute the values of a and b, capital X of s will become 2 upon s plus 1 minus 1 upon s plus 3. Therefore, if we take the inverse Laplace transform, x of t will become 2 into e to the power minus t minus e to the power minus 3t will be the answer for this question. Hope you have understood the inverse Laplace transform we have solved here using the partial fraction expansion technique. In the next question, two signals x of t and y of t are given to us. We have to find z of t, which denotes the convolution of x of t and y of t. This is a question of convolution, and we will solve this question by the Laplace transform technique. in the competitive exams also, I would recommend that you solve convolution questions through Laplace transform. So if x of t is e raised to minus t, then its Laplace transform capital X of s will be 1 upon s plus 1. Similarly, y of t is e raised to minus 2t. Therefore, its Laplace transform will be y of s will be equal to 1 upon s plus 2. Now, we have to find z of t, which is x of t convolution with y of t. If we apply Laplace transform, this will become z of s will be equal to capital X of s multiplied by capital Y of s. Please note that convolution in time becomes multiplication in s domain. Therefore, z of s becomes 1 upon s plus 1 into s plus 2. We will solve this by the partial fraction technique. So, a by s plus 1 plus b by s plus 2. So, a will be limit s is tending to minus 1 s plus 1 into capital Z of s. So, it will be limit s is tending to minus 1 s plus 1 multiplied by 1 upon s plus 1 into s plus 2. So, s plus 1 will get cancelled. If you substitute minus 1 in place of s, a will come out to be 1. Similarly, we have to find the value of b. The value of b will be limit s is tending to minus 2 s plus 2 into z of s. Therefore, this will be limit s is tending to minus 2 s plus 2 into 1 upon s plus 1 into s plus 2. S plus 2 will get cancelled. Therefore, b comes out to be minus 1. Therefore, we can write z of s as 1 upon s plus 1 minus 1 upon s plus 2. Then we will apply inverse Laplace transform. Therefore, z of t will become e to the power minus t minus e to the power minus 2t, which will be the answer to this question. Since the ROC is not specified in the question, I will express z of t as e raised to minus t minus e raised to minus 2t multiplied by u of t. In the next question, the impulse response h of t and the output y of t of a discrete time LTI system are given to us. We have to find the input x of t. Again, we can solve this question by using the Laplace transform technique. Now, the relation between output, input and impulse response is given by convolution, where we say the output y of t is convolution of input x of t and impulse response h of t. Therefore, if you apply Laplace transform, y of s will become x of s into h of s. Therefore, capital X of s will be equal to y of s divided by capital H of s. Now, since y of t is e raised to minus 3t u of t minus e raised to minus 5t u of t, y of s will be 1 upon s plus 3 minus 1 upon s plus 5. If we simplify this, this will come out to be 2 upon s plus 3 into s plus 5. This is simplifying by cross multiplying this fraction. Similarly, h of t will be equal to e raised to minus 5t u of t. Therefore, the Laplace transform capital H of s will be equal to 1 upon s plus 5. Therefore, x of s, which is nothing but y of s by h of s, will come out to be 2 upon s plus 3 into s plus 5 whole divided by 1 upon s plus 5. In this case, s plus 5 will get cancelled. So, capital X of s comes out to be 2 upon s plus 3. If you take the inverse Laplace transform, x of t will come out to be 2 into e raised to minus 3t into u of t. Therefore, in this question, the input comes out to be 2 into e raised to minus 3t into u of t. In the next question, the convolution of x of t with itself is given to be t into e raised to minus 2t into u of t. We have to find x of t. First of all, we should know the Laplace transform of t into e raised to minus 2t. Now, e raised to minus 2t u of t, the Laplace transform is 1 upon s plus 2. We will apply the differentiation in S domain property. In the differentiation in S domain property, if the left hand side is multiplied by t, then the right hand side is differentiated. Therefore, t into e raised to minus 2t into u of t, the Laplace transform comes out to be 1 upon s plus 2 whole square. So, the Laplace transform of t into e raised to minus 2t into u of t is 1 upon s plus 2 whole square. So, in this question, we have x of t convolution with x of t is equal to t into e raised to minus 2t into u of t. If we apply Laplace transform, then capital X of s multiplied by capital X of s comes out to be 1 upon s plus 2 whole square. Therefore, capital X of s comes out to be 1 upon s plus 2, because on the left hand side we have capital X of s square, whereas on the right hand side we have 1 upon s plus 2 whole square. Therefore, capital S is 1 upon s plus 2. If we take the inverse Laplace transform, x of t will be e raised to minus 2t into u of t, which will be the answer to this question. I hope you have understood how we have calculated the Laplace transform of t into e raised to minus 2t into u of t. In the next question, the impulse response h of t and the output y of t are given to us. We have to find the input x of t. Now, the Laplace transform of h of t will be h of s, and it will be 1 upon s plus 2. The Laplace transform of output y of t, I think we have already seen in the previous question, t into e raised to minus 2t into u of t, the Laplace transform comes out to be 1 upon s plus 2 whole square. Therefore, we know y of t is x of t convolution with h of t. Therefore, y of s will be x of s into h of s. Therefore, x of s comes out to be y of s divided by h of s. So, this will be 1 upon s plus 2 whole square divided by 1 upon s plus 2. So, x of s comes out to be 1 upon s plus 2. If you take the inverse Laplace transform, x of t comes out to be e raised to minus 2t into u of t. In the next question, the input x of t is given as unit step u of t, and the transfer function capital H of s is given as 1 by s. We have to find the output y of t. We know that y of t is x of t convolution with h of t. In this case, the Laplace transform of input capital X of s will be equal to 1 by s. Therefore, if we apply the Laplace transform, y of s will be equal to x of s multiplied by h of s. Therefore, if you substitute the value of x of s and h of s, y of s will become 1 by s multiplied by 1 by s. So, y of s will be equal to 1 by s square. If we apply the inverse Laplace transform, then 1 by s square comes out to be t into u of t. So, the answer to this question will be t into u of t. In the next question, a second order differential equation is given to us. We have to find the output y of t. The input x of t is also given to us. If we apply Laplace transform to the given equation, then this will be s square y of s plus derivative will become 4s y of s plus 3y of s. This will become 2s x of s plus 4 into x of s. Therefore, if we take y of s common, we will get s square plus 4s plus 3 is equal to, if we take x of s common, we get 2s plus 4. Therefore, y of s comes out to be 2s plus 4 divided by s square plus 4s plus 3 into capital X of s. X of t is given as e raised to minus 2t into u of t. Therefore, capital X of s will be 1 upon s plus 2. If you substitute the value, y of s will come out to be, if we take 2 common, this is s plus 2 divided by s plus 1 into s plus 3 multiplied by, this is 1 upon s plus 2. S plus 2 will get cancelled. So, y of s will be 2 upon s plus 1 into s plus 3. If we apply the partial fraction expansion, then 2 upon s plus 1 s plus 3 can be written as a upon s plus 1 plus b upon s plus 3. We have to find a and b to find the inverse Laplace transform. A can be calculated as limit s is tending to minus 1 s plus 1 into y of s. So, this will be limit s is tending to minus 1 s plus 1 into 2 upon s plus 1 into s plus 3. So, s plus 1 would get cancelled and the value of a comes out to be 1. Similarly, b is limit s is tending to minus 3 s plus 3 into y of s. So, this will be limit s is tending to minus 3 s plus 3 multiplied by 2 upon s plus 1 into s plus 3. Therefore, the value of b comes out to be minus 1. Therefore, y of s, we can write y of s as 1 upon s plus 1 minus 1 upon s plus 3. If you apply inverse Laplace transform, y of t will be equal to e raised to minus t minus e raised to minus 3t multiplied by u of t. In the next question, a differential equation and an integral differential equation is given to us. Therefore, two equations are given to us. One is a differential equation, other is the integral differential equation. From these two equations, using these two equations, we have to find out the Laplace transform of g of s. After finding the Laplace transform g of s, we have to answer how many poles are present in g of s. We would start with this equation by applying Laplace transform. If we apply Laplace transform, this will become s square y of s plus alpha s y of s plus alpha square y of s will be equal to capital X of s. Therefore, if we take y of s common, this will be s square plus alpha s plus alpha square is equal to x of s. Therefore, y of s by x of s will be 1 upon s square plus alpha square. But y of s by x of s is called as the transfer function h of s. Therefore, h of s will be equal to 1 upon s square plus alpha s plus alpha square. So, we get the transfer function h of s from the first differential equation. We will apply Laplace transform to the second equation. So, g of t would become g of s alpha square. Now, integration will be h of s by s. So in derivative, we multiply by s. In integration, we divide by s. Plus, again we have derivative, so we will multiply by s. So it will become s into h of s plus alpha h of s. Therefore, g of s comes out to be, this is alpha square by s plus s plus alpha into capital H of s. So if you simplify, this is s square plus alpha s plus alpha square whole divided by s multiplied by h of s. Now we will substitute the value of h of s in this equation. If we substitute the value of h of s here, then the g of s will come out to be, g of s will be equal to s square plus alpha square divided by s multiplied by 1 upon s square plus alpha s plus alpha square. Both these will get cancelled. So g of s comes out to be 1 by s. In the question, they are asking us how many poles are there in g of s. As we can clearly observe, there is only one pole in g of s, and that pole is at origin. Therefore, the number of poles in g of s is equal to 1. Therefore, the number of poles in g of s is equal to 1 is the answer to this gate question. In the next question, a differential equation is given to us and we have to find the output y of t. The value of x of t is also given to us. We start this question by applying Laplace transform. This will be s square y of s plus 3sy of s plus 2y of s will be equal to capital X of s. Therefore, y of s comes out to be s square plus 3s plus 2 is equal to x of s, but x of t is given as 2 into u of t. Therefore, capital S will be 2 into u of t will be 1 by s. Therefore, we can write y of s as 1 upon s square plus 3s plus 2 into x of s. Therefore, y of s will become 2 upon s into s square plus 3s plus 2. Therefore, y of s can be written as 1 upon s into s plus 1 into s plus 2. We now have to apply the partial fraction expansion. So, y of s will become a by s plus b by s plus 1 plus c by s plus 2. We have to find the values of a, b and c. A will be equal to limit s is tending to 0, s into y of s. So therefore this will be limit s is tending to 0, s multiplied by two upon s into s plus 1 into s plus 2. So ss will get cancelled. So a comes out to be 1. Similarly, we find the value of b. B will be limit s is tending to minus 1, s plus 1 into y of s. So limit s is tending to minus 1, s plus 1 into 2 upon s into s plus 1 into s plus 2. Therefore, this is 2 upon minus 1 plus 2. So b comes out to be minus 2. Similarly, we find the value of c, which will be limit s is tending to minus 2, s plus 2 into y of s. Therefore, limit s is tending to minus 2, s plus 2 into 2 upon s into s plus 1 into s plus 2. S plus 2 will get cancelled. So this comes out to be 2 upon minus 2 into minus 2 plus 1. Therefore, the value of c comes out to be 1 as 1 by s minus 2 by s plus 1 plus 1 by s plus 3. If we apply the inverse Laplace transform, y of t comes out to be u of t minus 2 into e raised to minus t u of t plus e raised to minus 3t u of t. So y of t will be equal to 1 minus 2 into e raised to minus t plus e raised to minus 3t into u of t. That will be the final answer for this will be the final answer for y of t.